Hi, my name is Jeffrey Nunez, and welcome to my first ever video series on YouTube. So, what is this series? Over the next many hours, I will be walking through my development of a puzzle game in Unreal Engine 4. This puzzle game is very similar to the well-known series Lumines. It's not a perfect recreation, but it has most of the major features you would expect. It's got the special block that can clear all adjacent same-colored blocks. So, I've made this game before when I was first learning Unreal, but now that I understand the engine a little better, I wanted to make an improved version of the game, and I figured a good way to test my experience with the engine was to try to explain it and teach it to someone else. So, when I set out to make this series, I didn't intend for it to be for absolute beginners to the engine, so I don't cover how to install the engine. I don't cover some of the basics of how to move around the interface, but even if you're completely new to Unreal, I do think you could watch this series because I go very thoroughly through every single action that I do and why I'm doing what I'm doing. I don't always say how I'm doing it, but if you've clicked on things and dragged and tried right-clicking on things, I'm pretty sure you'll be able to follow along if you watch the videos as you're programming in another window, so you have the videos on one screen and your editor on another screen. You should be able to figure out how to do pretty much everything. It's all just left and right clicks. Sometimes you hold a key down, but if you're absolutely new to the engine and you want to try to make this game with me, I highly recommend that you stick around for the end of this video, where I'm going to briefly demonstrate some of the helpful shortcuts that I use without even thinking about them. Like, throughout this series, I'll be using keyboard shortcuts like holding Alt and Control and clicking certain things to save a few seconds here and there while I'm making blueprints. And I didn't really think to cover how to do those, but at the end of this video, I'll briefly go through a demonstration of all the helpful tips that'll save you many hours over the long run if you learn them right away. So, what are we covering in this series? Well, we'll be starting from a completely blank project, as empty as you can possibly make it, and we'll be scripting every aspect of the game via blueprints. So everything from spawning in the actors and having the collision checks and creating the matches and changing the colors of everything and adding up the score. All this is happening in Blueprint, and none of it was assembled from pre-written components. Well, obviously the blueprints themselves have pre-written components underneath them for certain macros and stuff. And of course it's all C++ under the hood, but we'll be making blueprints for all of the actors in our scene, and starting from blank construction scripts and blank event graphs and populating that. Step by step, I'll be walking through every single function that I write, every single event that I script out. So if you follow along from the beginning, you'll definitely have the game you're seeing now by the end. And I hope to explain everything well to you so that you can learn a lot throughout this process, and then when you're done, you'll be ready to make puzzle games that are completely different to this one, and hopefully you'll be able to learn how to make games of any genre without too much more trouble. I can't say this project is going to set you up to make any genre of game in Unreal, because we don't have, complex skeletal animations, and we don't have multiplayer and online connectivity, so this is just pretty basic stuff. But there is quite a bit of nuance to the gameplay logic, scripting everything out correctly so that events happen in the right order, and different complex gameplay scenarios where blocks are in positions at different times. Try to minimize the potential for timing errors and bugs that can make the game unenjoyable. So there's quite a bit of complexity to the gameplay scripting here, but I'll be starting from the basics and covering quite a few things that you'd be interested to know, regardless of the genre of game you're making in Unreal. So just a short list of some of the topics we'll be covering. Everything from functions and events in blueprints, blueprint variables and enums, doing loops in Blueprint, including for loops, for each loops, and while loops, branch and sequence nodes, spawning in actors via Blueprint, using the construction script on an actor, scripting input actions, using tick events, using timers to initiate events and functions in Blueprint, using timelines to change values over time in Blueprint, without relying on tick events. Going over the different types of collisions and how to use ray traces to check for collisions. We'll be covering a bit of lighting and post-processing to make the game look a little better. We'll be using the material editor, and I'll be going over the difference between materials, material instances, and dynamic material instances. We will mess with skeletal meshes a little bit to do an animation on a cube to turn it into a bit of a sphere shape, and that'll be using morph targets. We'll be messing with Blender for just a brief moment to create a few different cube shapes. We'll be using the user interface editor to create widgets, along with widget animations for the text and boxes that make up the user interface. And all of these aspects are, of course, the necessary components we cover as we start from scratch trying to script the game. So we start by using the basic cube primitive to generate the grid that the cubes will land inside of, and then we make the cubes spawn, and then you make the player control the cubes. And we just go from the beginning and cover everything we need to in order to generate the gameplay that we're trying to recreate. So hopefully that sounds interesting to you, and if it does, then please stick around. I'm sure you'll learn something. Even if you're completely new to Unreal, I think you could learn something. Even if you've used it before, maybe I can teach you things you didn't know. And maybe you can teach me things I'm doing incorrectly or inefficiently in the comments. Because the whole point of this is that I want to get better at Unreal and get better at programming in general. So hopefully by trying to teach other people how to use Unreal, I can improve my own abilities. One disclaimer I'll make up front is that this is not going to be a short and concise video series. It's going to be quite lengthy. I would imagine somewhere in excess of 10 hours of video, maybe even longer. I hope to offer something unique with this series by showing literally every step of the programming process. When I'm developing this game, I even put a bit of pseudocode on screen for one of the more difficult algorithms that I run into. So I have edited these down. The raw videos are somewhere around 30 hours total, so hopefully it's about half that length, if not shorter. But I've cut out a lot of the pauses in my commentary and the ums and uhs that I've probably sprinkled throughout this introduction without intending to. I say that a lot, so I try to cut most of those out, but I did leave in some parts where I am thinking and then making changes and making mistakes and fixing those mistakes, because I need to keep some of those in just for context. If I cut out every single mistake that I made, then you might lose context of, oh, where do you get from here to there? Like suddenly there's more nodes on screen that weren't there before. So I kept what I needed to keep in the videos to try and keep everything clear and understandable. So I also leave some text comments on screen at points where I've made a mistake but I haven't realized it yet. So sometimes even several videos later there'll be a change or a correction, and I'll try to put a comment on screen when that's something that can save you some time so you don't make the same mistakes I was making, or so oh, I'm going to fix that later. But I did cut out quite a few times where I would spend 30 minutes writing a function and it ended up not working properly or not doing what I needed to do. I try to edit around those in a way where it makes sense, where I'll fade out and then fade back in and say, okay, I just did this and it didn't work, so now I'm going to do this instead. Hopefully there'll be enough context in the videos for you to know when I'm going down the wrong path so you don't make the same mistakes that I was making. And if you do, well, that's part of the process of learning it, is to make some mistakes, because that's how I did this. I recorded these videos as just a stream of consciousness, developing the game and recording. And I tried to comment on everything I was doing, and then I just cut out all of the boring parts, quote unquote. A lot of this is probably going to be pretty boring if you're not really excited about learning Unreal, or really excited about Lumines in particular, because I will do a lot of commenting on the nitty-gritty details of how Lumines works and how I'm trying to replicate that functionality and what sequence of events we need to have happen in order to achieve that functionality. So hopefully that sounds interesting to you, and if it does, then I think if you follow along, you're going to have a lot of fun and learn quite a bit. And I think it's true that one of the best ways to learn anything is to try to teach other people how to do it. So without any further ado, I think we'll get into the demonstration of the helpful keyboard shortcuts and mouse shortcuts that I'll be using throughout the whole video series. So stick around if you're new and you want to see some shortcuts that I'll be using throughout the series. So let's go ahead and get into it. So I'm here in the default level that Unreal provides you with when you start a new project. This isn't going to be part of the project that we're making. I'm just here to show you some of the basics of working in Blueprint scripts and working within the editor to do a couple keyboard shortcuts that I use all the time that will save you a few seconds here and there whenever you use them. And they're really handy to get a hold of early so you can be as efficient as possible. So we'll go ahead and get started with, I'm going to just, I haven't done anything to the scene. I'm just going to add a cube to the scene and just got a default white texture on it, white material. And all I'm going to do is, this isn't something we're going to be doing in the real game, but I'm just going to add a blueprint to this object so that I've turned this object into a scriptable, reusable class here. And the reason why I'm going to do that is so I can show you blueprints. There's no other actors in this scene that are doing anything right now. So when I left click on this or double click on this in the content browser, it'll open up the blueprint editor for it. And then you want to go to the event graph. This is where you're going to do all the actions that our actors are going to perform in the game. So the main way that I add actions to this graph is to right click anywhere inside the graph here, and then that'll open up this context menu. And then here you can add like any action you can possibly perform in blueprints here. Just a test goal right now is just going to have the cube like float up into the air. So just like fly straight upwards. So to do that, I will use the tick event. So events are like the hooks into your blueprint. So the code, like the engine, is going to run the game, and then it will call these events when certain things happen. The events are your chance to then plug in your logic that you want to add to your blueprint, and then that's how it'll execute it. So when the game is running and one of these events begins, then then the logic flow, the control flow of the program is going to enter this blueprint and come out of this white pin here. This is called like the execution pin. And whatever event is executing, the control flow is going to come out of here. And then, so you can left click and drag out of here, and then the context menu will appear. Or you can right click anywhere and then write something and then connect the pins up. And sometimes you get different contexts. Like here, you can only do things that are immediately executable. And here you can do things that don't have an execution pin. Like I can say get game mode. And this is a pure function that doesn't have execution pins on it. A lot of nodes will have pins on them. This one does not. Here I can't type get game mode. So it really depends on whether you need something with execution pins here when you're dragging out of here. But I rarely drag out directly from an event like that. I sometimes might, but usually I right click and think, what am I trying to do? And then type it here and then connect things up later. But to get this going, I'm going to right click and type get actor location, which gets the world location of the current actor whose blueprint we're inside of. So what I want to do is make this guy fly upwards, this cube. So I'm going to run the set actor location function. And we need to change our current location to a new location. And the end result is we want it to move upwards. So I'm going to connect the execution pins like that. And then we don't need to get the game mode. So you can click and drag to highlight multiple things, or you can just click them and then hold control and click multiple things. Then you can press the delete key to delete them, or you can right click and delete, but I always just use the delete key. Now let's make a variable on this blueprint so we can set a velocity that we want our cube to have. So I'm just going to call this velocity, but you could call it something more descriptive if you're doing something more intricate. And so a vector obviously has three elements, three components, an X, Y, and Z element in our case here. The direction that we want is just going to be straight up along the Z axis. So we look back in the world. The X axis is shown by this red arrow. This green arrow is Y, and this blue arrow is Z. And you can see that in the coordinate system down here. So I'm going to make us move up along the Z axis. So I'm going to make our velocity have a default value up in this details panel. You can set the default value for whatever variable you selected. So I'm going to set our default value to something like 200 in the Z axis. And then you press compile to make your changes have like take effect in the compiled blueprint. So we want to move our actor a certain distance according to our velocity. So to get the actual distance traveled, we need to multiply the velocity, which is, distance over time, by some amount of time to get the actual distance. So what delta seconds does, this is a data pin. These circular multicolored pins are data pins, and the white pins are the execution pins. When the tick event is called, this argument comes along with it, and it tells you how much time in seconds has elapsed since the previous tick. And ticks are the way that the logic in the game progresses. So things like the physics and character behaviors can update per tick. We want to multiply our velocity by the time that has elapsed since the previous tick, so that we can have a constant speed regardless of what the actual frame rate is right now. So we can multiply a vector times a float. These green pins are floats, the yellow pins are vectors, everything's color coded, and you'll just get used to those colors over time. So if we can just drag off of here and then release and type the asterisk key, which is the shorthand for multiply, so vector times float, and then click and drag the pins to wire them up. And then when they're wired up, you can click and drag to move the nodes around. These are called nodes, by the way. I don't know if I said that, but every little event here, every action has a node, and then you wire up the nodes to create the logic. Anyway, we're multiplying velocity times the delta seconds. This needs to be added to our current location to result in the new location that we want to end up in. So vector plus vector, and then wire up the pins, and then this output goes to the input of this node, and that should accomplish what we want to have happen, which is just at a constant rate we're going to move upwards every tick. The distance will be based on how long the tick was, but in real time it should be approximately the same constant velocity. So now we should just be able to go to the editor here and press play. I'm going to press play in the selected viewport. Before I press play, I realize there's something I need to change. This cube is by default, if I go to the details panel, it's set to be static, so it's not going to move. So we need to change it to the movable setting here so that it'll actually move during gameplay. So if I press play now, I think the camera will move because, oh yeah, there it goes. So what just happened, a couple things I need to, this player start is where the player's camera in the default game mode. We're running the default game mode right now, but when you open up this default map, it gives you a player pawn to possess, but I don't really care about that. I just want to show you this cube. So I'm going to move the cube in front of the where the camera is going to be started when the player presses play. So when I press play, the cube's going to fly up, and it looks like it's going too fast, so I'll just go ahead and slow it down a little bit by changing our velocity variable to like 30 instead of 200, and then compile, save, and then play again. And we can see it flying up right now, and depending on your game mode, when you press the play button, the mouse might be locked in to the viewport here. So if I click inside the viewport, the mouse is now locked into the viewport and I'm controlling the default pawn. But if you want to play the game and then eject from your pawn, you might be like, how do I eject? I can try to press the escape key, but then it stops the simulation, and then whatever you wanted to watch happen is no longer happening. So the keyboard shortcut to reclaim control of your cursor while the game is playing is, so the cursor is now in the game. If you hold shift and press F1, the F1 function key, then you have cursor control again. And it does say that up here in the top left corner, shift plus F1 for mouse control. But that's a pretty handy shortcut that I use that a lot in the video series, and just so that you don't get confused, that's how I'm doing it. The game is playing and I'm doing stuff, but then I want to, debug something. So I press Shift F1 and then I go up to eject, and then you can pause and fly around the world. So what I'm doing now is I'm flying around the world in the editor, and this is different from what I was doing a minute ago when I was flying around with the default pawn while the game was playing. So this is the actor that represents the default pawn here, but no need to worry about that. That's not going to be part of our project. That's really all I want to show you in the viewport was Shift plus F1, and we're pretty much ready to go. Another very useful keyboard shortcut is when you're dragging a variable from the left-hand side here over to the graph. When you just left-click and then drag and release, it's going to ask you whether you want to get the variable or set the variable. So get means one of these nodes where you just read the value. When you want to write to the variable or modify it, then you have to use the set option. And right here it says you can alt drag to automatically do it, and control drag to automatically do it. That's what I do 99% of the time. I'm always holding alt and then doing this, or holding control and doing this. So in the videos it might be confusing how I'm doing that so quickly, but that's what those tooltips so helpfully tell you, is you can hold alt to set automatically and hold control to get automatically. And that saves maybe a quarter of a second every time you do it, but it saves you a click, and when you click 10,000 times, you've saved 2,500 seconds. So that time adds up. So there's a lot of ways to reroute your pins and change your execution flow around. Only one execution pin can come out from any particular node, but multiple pins can go into the same node. So like these can both do the same sequence of events over here, but only one execution pin output is allowed from each node. So if you want to quickly remove a wire, you can hold the Alt key down and then just click the wire, and it just deletes it. And if you want to move, so say I wanted to do this instead of this one, then I could hold Alt to remove this and then do what I just did there. But you can also hold the Control key down and then click and drag this, and it modifies that same wire. So then you can move the pin from one node to another and use that same wire without having to destroy that one and make a new one like that. Again, it seems trivial and seems arbitrary, like it's not really that much faster, and it's not, but over time it can save you a lot of clicks and quite a bit of time. So that's another handy little trick. So to review, mainly there's just like 5 tricks that I wanted to show you. There's this one, there's holding Alt to remove the wire, there's holding Alt or Control to quick select either get or set, and then there's obviously the right click context menu to enter whatever function you want to call here. And that's really all the basics you need to get started. So in the next video, we'll start a blank project and get the grid up and running, the grid in which all the action takes place in Lumines. So I'll see you then.